Hi, grade 12 students. We're going to continue by the derivatives. The lesson today is very simple. It's derivative of integrals. We know that if we have an integral of f of x dx, big F of x is the antiderivative. And if we derive the antiderivative, which is fx plus c, in the answer, the primitive or called antiderivative, we're going to get the function inside the integral, which is called integrand. So derivative always of the answer, it will give me insight. So if I want to do the derivative of this integral at the same time as doing the derivative of its equality, which is f prime of x. And since f prime of x will give you f of x, so derivative of the integral of f of x, it will give you f of x. So when you want to derive integral of f of x, it will give you directly f of x. So this is the property. Let us take an example. So if you want to derive 2x ln x minus 5 over e power 2x minus 3 dx, it will give you again 2x ln x minus 5 over e power 2x minus 3 without any change. So derivative of integrals is the same as the integrand, which is inside. Second one, if you have from a to b, we all know it's antiderivative f of b minus f of a. Since a and b are constants, so you're going to get a constant. And we know the derivative of this integral is the same as derivative of a constant is 0. So derivative of any definite integral from a number to a number, if you have a number from a number, so directly the answer is 0. The previous example we didn't have, it was an indefinite integral, so we don't have anything, so you write the integrand as it is. However, if you have two numbers, for example, like here 5, 7, directly the derivative of the integral is 0. Suppose I have a constant down and a variable up. It can be x or it can be any expression. We all know it's the antiderivative of g of x minus f of a. And if I want to derive this one, it's the same as deriving the answer. So if I want to derive fg of x, this is a composite function. It will be g prime of x into big F prime of g of x. And derivative of f of a is 0. Why? Because this is a constant. And derivative of a composite function, as we said, is g prime into f prime of g of x. But since f prime here is f of x, so it will be g prime of x into f g of x, because big F prime is a small f. So the property is, if you have a constant down and a variable up, what do? We derive first of all this variable outside, and then we replace this variable inside in f of x. Let us take example. So here I have a number, here I have a constant. So if I want to do the derivative of this one, so first of all I derive 2 sine x. Derivative of 2 sine x is 2 cosine x. So I open big parentheses. For every x I have inside, like here and here, I replace it by 2 sine x. So you're going to get 2 ln 2 sine x minus 3 sine between parentheses 2 sine x. Another example here, I have here a constant down and a variable up. I want to do the derivative. First of all, I derive 2x squared minus x. It is 4x minus 1. I have here x and here x. These two x's, I replace it by 2x squared minus x. So I get 2e power 2x squared minus x over 3 sine. I will write instead of this x 2x squared minus x. Now suppose I have the constant down and the variable up. So you know this is the answer of the integral. So if I derive it, derivative of a constant is 0. Here it's a composite function. So it will be g prime minus, because I have minus before, g prime of x big F prime, but big F prime is a small f. So if I have a constant, the same as the one we did up, but we put before what? Minus. So let us take this application. I have a constant up and I have a variable down. So I put minus first of all. Derivative of 2x minus 3 is minus 2. I replace every x here by 2x minus 3. You can see then 2x minus 3 minus 2 into 2x minus 3 square. Okay. Here, this is an example where not to compare the two, where the variable is up and the constant is down. So I derive up, as we said, 4x minus 1, and I replace this x by 2x squared minus x into 3 sine 2x squared minus x. So when I have a variable down, it's the same as up, but here I put minus, here I don't put a minus. The last one, if I have a constant up and a constant down, we combine the two above. Okay, so let us take an example. If you want to do the derivative of this one, I start by up. I do the derivative of 2 sine x, it's 2 cosine x. I replace this x and this x by 2 sine x. You're going to get 2 ln 2 sine x minus 3 sine 2x. Then I take down derivative of 5x is minus 5. And I replace 5x here and 5x here, as you can see. I want you to do the derivative of the following integrals as a homework. Try to do it. Okay, and then check your answer here. These are the answers of above. So you have this one and you have the answers. Remains one thing to talk about. Limits using Hospital rule with integral. This is simple also. Suppose I want to do limits as h tends to 0 of this whole expression. As if I have denominator here h and integral from O to h of this expression in numerator, because this can be as all over h. So if you replace by 0, you have denominator 0. If you replace h by 0, you have 0 from 0 is 0. So the limit, you're going to get 0 over 0, so we apply Hospital's rule. So we derive up over derivative down. Derivative of h down is 1. Derivative of this integral, as we said, because I have h, derivative is 1. I replace every h by h, so nothing will change. Cosine h minus 3h plus 2. Here I have, sorry, minus 3h minus plus 2. I have a mistake. So now, if you replace h by 0, what do you get? You're going to get 2 minus 3h is 0, okay? And plus 2, you have here plus 2, you're going to get 4. So I'm going to repeat. If you want to derive it, what do you get? You're going to get, you put 1 outside, you have 2 cosine h, you replace h minus 3h plus 2 all over what? 1, because the derivative of h is 1. Now we replace h by 0. Cosine h is 1. 1 times 2 is 2. Minus 3 times 0 because h is 0 plus 2, so the answer is 4. Now if you have this one, if you replace h by 2, you have here 4 minus 4, denominator 0. And if you replace also h by 2 from 4 till 4 integral, it's also 0. So I do the derivative. Down, it's very easy, 2h. Up, what do? We derive 2h, it is 2. And I replace every h inside by 2h. So you're going to get 2 into 2h all squared. Minus 3 times 2h is minus 6h minus 5. I have h tends to 2. I replace h by 2. 2 times 2, 4. 4 squared, 16. 16 times 2, 32. Minus 12 minus 5. 2 and 2 here cancel out. Over h, which is 2. So you're going to get 20 minus 5 is 15 over 2. So as you can see, this lesson is very easy. Hope that you understood everything, and see you tomorrow in school.